Okay, today we're going to be talking about the distance and midpoint formulas in this video. First off, let's talk about what they're actually used for. The distance formula is used to find the distance between 2 points, and we'll call these 2 points x1, y1, and x2, y2. And these 2 points, we all know what points look like. The actual points might be something like 2, 3, and 5, 7. To where you have your first x and your second first y and your second x and your second y. The actual formula for distance is equal to the square root in parentheses of x2 minus x1 squared, and we see what the x2 and x1 are. They're in this case would be the 5 and the 2 plus y2 minus y1 squared. And we again see what the y2 is. The y2 is your second y, and the y1 will be your first y in the 2 points. We'll also look at a shortcut that I like actually better. We can actually use what we refer to as the Pythagorean theorem to also find the distance between 2 points, and I prefer that method so much more. And I'll show you both ways, and you can pick whichever method that you like best. First problem says find the distance between these 2 points on the graph. The point here and the point here. Well, first off, we need the 2 points. The first point, we'll call this our first point down here. It doesn't matter which is which. The first point is at -2, -3. And your second point is at -5, and your y value is 3. So using the distance formula, the distance is equal to the square root. And you can look back if you need to, but it's x2, which again, your x values are the -2 and -5 here. So x2 would be -5 minus your x1 would be -2. And we know that minus a minus, anytime you have two minuses next to each other, that makes a plus. Y2 is 3 minus y1 is -3. And the exact same thing, anytime you have a minus minus, make that a plus. So our distance here is equal to the square root. Parentheses will always be first. -5 plus 2 gives me a -3. 3 plus 3 gives me a 6. So that'd be the square root. We now square each of these. That'd be 9 plus 36, which is the square root of 45. And anytime we do these, there's 2 different ways we can leave our answers. The first method, we could actually find the exact value, root 45. We can split that into the square root of 9 times the square root of 5. And if you don't remember why I'm doing this, you can go back and review how to simplify radicals. Square root of 9 is 3. The square root of 5 we leave, so that'd be 3 root 5. The other method would be we could type that into our calculator, and we see that the square root of 45, we round that to the nearest decimal tenth, is about 6.70 or 6.7, round to the nearest tenth. So this would be if they ever ask you to leave your answer as exact, or this would be an approximate answer. Now let me show you the second method. We can also do this problem using the Pythagorean theorem, because we see here that if we were to draw a vertical and a horizontal line, the distance here is actually, if you remember back Pythagorean theorem, the distance here is actually the c value of a right triangle. So what we can do to use Pythagorean theorem is we can find the distance from one of our y values to the other y value. We can find the distance from our x value to our x value, and we can just simply use those two distances and perform the Pythagorean theorem. And let me demonstrate that now. Take your two x values, which is -2 and -5, and ask yourself how far, and you can think about a number line if you need to. This is 0, -1, -2, -3, -4, -5. We ask ourselves how far is it from -2 to -5 on a number line, and that distance would be 3. And then do the exact same thing for your y values, and ask yourself how far is it from -3 to +3 on a number line, and that'd be 6. take those two values, and that would be a 3 here. Oops. Scroll up just a little bit. That would give me a b value. Let me erase the b and a now. That'd give me a b value of 3, and you can actually count the boxes there and see the exact same thing. A b value of 3. Count the boxes here. That gives me an a value of 6. And just perform the Pythagorean theorem, a squared plus b squared is equal to c squared. And notice what you get. You'll get 3 squared is 9. 6 squared is 36 equals c squared. 9 and 36 gives me 45 is equal to c squared. To undo a square, we square root the other side. The square root of 45, we get the exact same answer we got as before. And that's, again, I'll work one more with the distance formula, but that's going to be my method that I most of the time will use for these. Again, if you'd like to use the distance formula, the distance formula is this. Distance is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. Where again, x2 and x1 are our two x values in our points. So on this problem, we have the square root in parentheses of 3 minus, the first x is negative 4. Minus minus, we always turn into a plus. The second y is negative 1 minus the first y is positive 1. And notice there we don't have the negative, so we leave it. So that turns into 3 plus 4 would be 7 to the second power. Plus negative 1 and negative 1 is negative 2 to the second power. We now square each. Square root of 7 squared is 49 plus negative 2 to the second power. Now I want to point out something, that anytime you square something, you're always going to get positive values here. There's never going to be a negative value left. So negative 2 to the second power would be 4. That'd be the square root of 53. And you can try to break that down, but it will not. So that's going to be your exact answer. If you're looking for an approximate answer, that's going to be about 7.3. So I'm going to put my approximation symbol here, about 7.3. So there's your two answers. Okay, from here on out, again, I'm going to use Pythagorean theorem to do these problems, just because I feel like it's a little bit quicker. So to use Pythagorean theorem, again, all you've got to do is ask yourself, how far is it from negative 7 to 11? And that's going to be 18. From negative 7 to 0 would be 7. From 0 to 11 would be 11 more, so that'd be a total of 18. This is the distance. Then ask yourself, how far is it from negative 2 to 3? And that'd be 5. Then it's a simple Pythagorean theorem problem. A squared plus b squared is equal to c squared. When we square 18, we get 324. So we get 324 plus 5 squared is 25 equals c squared. That's 349 is equal to c squared. To undo a square, we square root the other side. The square root of 349. We can look for an exact answer by trying to find two values that we can break 349 into, to try to simplify this down, if you would like to. However, I don't think this one will simplify. So that means that your exact answer will be just the square root of 349, or if you want an approximate answer, let's do the square root of 349, and I get about 18.7 approximately. Okay, next up we're going to talk about the midpoint. And if you don't understand what a midpoint is, by definition, if you've got a line segment, the midpoint is exactly what it says. It's the middle point. It's the point that's halfway between the endpoints of that line segment. It cuts it perfectly into two equal in length line segments. The formula for midpoint, and we'll call it MP. The midpoint of a line segment is a point, so therefore we're going to put it in parentheses, is equal to the first x plus the second x divided by 2, comma, the first y plus the second y divided by 2. Now, I want to cover a concept with you here that anytime that you're looking for the middle of something, um, the middle, another name for the middle is called the average. If you score, let's say that you score an 80 on a test and a 90 on a test, and you want to figure out what your average is, that average is going to be directly in the middle. It'll be the 85, the value in the middle. So I want to point out that in this midpoint formula, that what you're actually doing is you're averaging your two x's. You're figuring out which x value is in the middle of the other two x's. So sometimes you can actually look to see the answer and you don't have to perform the actual steps. But find the midpoint again, you average your two x values, you add them and divide by 2, which is the process for finding the average of two numbers. And then you're going to add your two y's and divide by 2. Number 4, the first problem, it says find the midpoint of GH, given that G is 7, negative 5, and H is 9, negative 1. So using the formula, we're going to do the first x plus the second x, which would be 7 plus 9, and we're going to divide them by 2. And then we're going to do our first y plus our second y. We're also going to divide that by 2. And we should already know what our answer here is going to be. When you do 7 and 9, again, we're looking for the average here, but when you add them, you get 16 divided by 2, which is going to give you 8, which we already knew that 8 is the value directly in between 7 and 9. Negative 5 and negative 1 is negative 6. When you divide that by 2, it gives you a negative 3. So the midpoint of this line segment is going to be 8, negative 3. Find the midpoint of this line segment now. Again, what we're going to do is we're going to take, to find the midpoint, we're going to do x1, you see our formula up here, x1 plus x2, which is going to be negative 7 plus 3. We're going to divide them by 2. Y plus y is going to be 4 plus negative 4. We already know what's between 4 and negative 4, and we're going to divide that by 2. Negative 7 and 3 is negative 4. When you divide that by 2, again, I'm skipping a step here, but the top is negative 4. I'm going ahead and adding it. And when you divide that by 2, it gives you a negative 2. When you add 4 and negative 4, it gives you 0. When you divide 0 by 2, it gives you 0. 0 divided by anything would be 0. So if you were to construct this line segment and draw at negative 2, 0 would be the point directly between the endpoints of that line segment. Okay, now we're going to work the problems actually backwards. We're given a midpoint and an endpoint. We're asked to find the other endpoint. Now, I'm going to skip straight to an easier way of solving this, and I'm going to give you a shortcut. I'm going to go back and use these last problems to describe why this shortcut works. On this last problem, and I'm not drawing this correctly, I'm just to give you an idea, negative 7, 4 is one endpoint, and 3, negative 4 is the other endpoint. The reason I'm saying I'm not drawing it correctly is because I know that negative 4 and positive 4, that this would be flipped around. But just to give you an idea here, I want to show you something. So your endpoints were negative 7, 4 and 3, negative 4, and you had a midpoint at negative 2, 0. And I want you to keep in mind that the distance from here to here is the same thing as the distance from here to here. That's what actually makes it a midpoint. Well, that means that the distance from this x value over to this x value would be the same as the distance from this x value to this x value. And the same thing with your y values. The distance from here up to here would be the same as the distance from here up to here. So what you can actually do is look at these x values. And if done correctly, these x values should be stair step. They should be the same distance. In other maths, we call these arithmetic sequences. And let me give you an example of an arithmetic sequence. That'd be like the sequence 2, 5, 8, 11, 14, to where notice that the step from here to here is the same as the step from here to here. You're adding 3 each time. If done correctly, you can actually use, let me take that off. You can actually use arithmetic sequences to find the different parts here. Because if you notice, from -7 to -2, you add 5, and from -2 to -3, actually, did I write down the wrong? That should be a +3 there, my bad. From -7 to -2, you add 5. From -2 to +3, you add 5 again. And notice your y values. From 4 to 0, you subtract 4. From 0 to -4, you subtract 4 again. So therefore, you can actually use arithmetic sequences to find missing parts. Let me show you how to do that here. Here it says you have a line segment, and it gives you one of the endpoints, and it gives you a midpoint. It says one of the endpoints is at 3, -5. The midpoint is at -1, 2, and it asks you to find the other endpoint. And all you have to do in order to find that other endpoint is look at your x values from 3 to -1 and just ask yourself, if this were an arithmetic sequence, how far down from 3 to -1 am I going? And we know that if you were to subtract 4, 3 minus what would be -1, because we know we're going down, and that would be a value of 4. So if we go down 4, in order to find the other x value, simply subtract 4 again, and that'd be a -5. So take that -1, subtract 4, and you can see that sequence there, that arithmetic sequence, 3, -1, blank. Subtract 4 again, and you do get that -5. And the same thing with our y values, from -5 to 2. We know we're going up now, and we ask ourselves, how far up did we go? From -5 to 2 to blank, and that's going to give us our other y value. We know if we add 5, we would get 0, so we're actually adding 7 here. So if you add 7 again, that would give you a value of 9. So the other endpoint would be at -5, 9. Now the next one I'm going to work without actually drawing. It says find the coordinates of j if k is -5, 10 and the midpoint is at -8, 6. So we have an endpoint at -5, 10. We have a midpoint at -8, 6. And we're asked to find the other endpoint. So simply look at your x values, -5, -8. We went down 3, so go down 3 more. That'd be -11. From 10 to 6, we went down 4, so go down 4 more, and that'd be 2. So -11, 2 would be our other endpoint. The next one says find the coordinates of r if q is that, and the midpoint is 5, 6. So one of our endpoints is at -1, 3. Our midpoint is at 5, 6. And we're asked to find the other endpoint. So from -1 to 5, we went up 6, so we go up 6 again, and that gives me 11. From 3 to 6, we went up 3, so go up 3 again, and that gives me 9. So 11, 9 would be my other endpoint. And you can always check that if you remember the midpoint formula. Here's your two endpoints. You should be able to add your x's, -1 and 11, because the formula is x1 plus x2 divided by 2. So you should be able to add your x's and divide by 2, and add your y's and divide by 2, and look what you get. 10 divided by 2 is 5, 12 divided by 2 is 6, so it checks out. More practice with algebra says if P is the midpoint of xy, now this one's a little bit trickier because now we're not going to be able to use, well, they're asking something completely different here though. It says P is the midpoint of xy, so let's draw that. So you've got line segment xy, and P is in the middle. It tells you the value of 8xp is 8x minus 2. The value of py is 12x minus 30. It says find the value of x, and we know again that what a midpoint is the point that's directly in the middle. So if we know that if P is the midpoint, that this line segment must be the same length as this line segment. So we know that 8x minus 2 would have to be the exact same value as 12x minus 30. And then we have a simple linear equation to solve. I'm going to take my 8x's and I'm going to move them to the right side by subtracting 8x's. I'm going to take my minus 30 and I'm going to move it to the other side by adding 30. I now have 28 is equal to 4x. Divide by 4. So we see that x has a value of 7. And number 10 says if G is the midpoint of FH, and I think it's a similar problem. So you have a line segment FH that has G as a midpoint. It says FG is 14x plus 25. It says that GH is 73 minus 2x. And again, we know if G is the midpoint that these two line segments have to be the same length. So we know that 14x plus 25 has to equal 73 minus 2x. Get rid of minus 2x by adding 2x to the other side. Get rid of plus 25 by subtracting 25 from the other side. Gives me a value of 16x equals, I believe that would be 48. Get rid of 16 since they're being multiplied by dividing, and you get x has a value of 3. But always go back to your problem and ask, did I find what I was supposed to find? It says find FH. FH is the value of the entire line. It's the distance, the length of the entire line segment. So what we're going to do, we're going to go back and we're going to plug that x value of 3 in. We're going to find out when you plug in 3 here that you have now 14 times 3 is 42 plus 25. That gives you a value. FG would have a length of 69. When you plug in the 3 here, it's not cooperating. There we go. That GH, when you plug in the 3 here, that would be 73 minus 2 times 3 would be 6. 73 minus 6. Give me 67. So let me go back and double check my work here, and I did. I messed up here. 14 times 3 would be 42 plus 25. Give me 67. And I want to point out what actually happened there, and I'm glad that it happened the way that it did, because I knew that the way I set up my equation that G needed to be the midpoint, which notice what I've got here. FG is 67, and GH is also 67. So therefore, since each of these line segments are 67, I know that G is definitely in the middle now. So I'm asked to find FH, so now I can use these two values to find. If FG is 67, GH is also 67, then the whole thing, FH would be 134, which all I did there was add 67 and 67 together. Number 11, the last one says, use the diagram to the left if line N bisects, and let's review the word bisects. To bisect something means to cut it in half. So if line N cuts QR in half, then find the value of QP. So the exact same premise here. If it cuts it in half, then that means that point P has to be the midpoint, which means again that 3x plus 5 would have to be the exact same length as 5x minus 19. We move 3x to the other side by subtracting 3x, and I did that to stay away from negative values. I moved minus 19 by adding 19. Now I've got my x's on one side, my numbers on the other. I have 24 is equal to 2x. To get x by itself, since those are being multiplied, I divide by 2, and I find out that x is 12. And if x is 12, everywhere we have an x, we can now plug in the value of 12. So I have 3 12s is 36 plus 5 gives me a value of 41. And I should see 5 times 12 is 60 minus 19, that the other side is also equal to 41. So the value from, or length from Q to P is 41, P to R is also 41. So they ask you for the length of, find QP. So the value of QP, the length of QP would be 41 there.